My name is Chris Ford. I did the keynote yesterday from Pixar Animation Studios. I suspect probably most of you were there. Is there anyone who wasn't at the keynote yesterday? Cool, okay, so there are a few people. So what I'm going to do over the next hour is essentially expand upon the themes that I covered in the keynote, which is how the business of rendering movies is probably ultimately going to move to the cloud. And I'm going to describe in more detail the research we did into finding the optimal model for cloud rendering and essentially how we think that this is going to evolve in future. So a lot of this is going to be lessons learned. But just as importantly, I want to make this kind of an interactive session afterwards. So I've left a bit of time for questions and answers in case any of you would like to ask me anything about our experience of rendering movies on the cloud. And I keep hitting this button. So I manage the RenderMan business at Pixar Animation Studios. Pixar is a movie studio, as you know. We make animated feature films, but we also provide much of the technology used to produce photorealistic imagery for feature film production. And we license that technology to various studios. We've been doing this for a long time, since 1987, 1988. Essentially, we invented much of the basic technology used to create these amazing images, and there are very specific milestones you can associate with photoreal imaging with movies. For example, the original Toy Story movie, everything was kind of plastic because that's all we could do. When we got to Monsters, Inc., we had a furry creature. One furry creature. That's all we could do. By the time, then we had Nemo with underwater lighting effects and caustics. By the time we got to Ratatouille, we had lots of furry creatures. And this is a very disobedient presentation. I think there's some order transitions built in. And throughout this period of time, we've made this technology widely available in the industry for people to render their special effects. Thank you. So RenderMan has been used in 19 out of the last 21 movies that were given an Academy Award for visual effects. And it's not just movies. It's also feature animation, it's game cinematics, it's scientific visualization, many of those NASA movies of Mars rovers bouncing around. All of that also uses exactly the same technology. So this is a fairly specialized and niche, if you like, usage of high-performance computing to generate amazing quality images, but a really interesting case study as far as seeing how it can be applied to the cloud. As I said yesterday, what this is all about is extreme photorealism, right? A typical movie will have literally hundreds of thousands of individual discrete frames that are generated. You think of the film, it's split into shots, right? Each of these shots, there may be 3,000 in a movie. When you think of all the testing, there's a huge amount of these images which are generated. And this is a highly parallel process, right? Because frames are, by their very nature, discrete and distinct entities. So being a parallel process, the cloud is highly relevant to this form of computing. So if you're working in a typical movie studio, every day you're doing this. You're just doing a lot of reiterative lighting and shading of objects. The teapot here is, if you like, a standard iconic shape in computer graphics because it has a nice combination of curves and topology to test out various things, and we've adopted it as our mascot. We actually have little walking versions. But this application of textures and lights and shaders to materials, this is the bread and butter of a studio's work. It's what you do most of your day. In fact, if we look at a day in the life of a typical studio, and you're working on lighting and shading, you can see that actually most of it is going to be spent rendering pixels. Certainly, you can see here, the 4 hours make it pretty. You spent a lot of time doing that. And then when you're finished, you'll eventually launch the images that you've set up to a render farm or a data center to actually render those images overnight, and then you come back. So the challenge of all this, as I mentioned in my keynote yesterday, and I'll reiterate here again, is that we're looking at films that have a huge computational requirement. You know, an average, say, 110-minute film, 6,600 seconds, 158,000 frames at 24 frames a second. And there are always interesting dimensions that come into feature film rendering that you don't think about. For example, stereo movies. Became popular a few years ago. You might think that would double the number of frames. And essentially it does. You need left and right. You have high frame rates, where you might go to higher frame rates than 24 frames a second, 48 frames a second, or 96. That, of course, increases the amount of compute required to produce these images. And the time it takes to do a cinematic movie frame can be anywhere between 9 and 100 to 500 hours per frame. Now, those are worst cases, but these take a long time to actually do. A movie res, a cinema res, certainly an IMAX res, you're looking at least 16 million pixels, which have to be individually generated per frame, which is a ridiculously large number of pixels for any movie. And a very large amount of time needed to render all that. And of course, we're dealing with deadlines all the time, which you can never, ever miss, certainly not in the film industry. And in fact, our movies kind of show over the years that the time for rendering has always remained fairly consistent, even though computers have become vastly more powerful, there's more memory, the CPU cycles, all of those are far more abundant now than they were in the past. But you notice that movies always seem to take an average certain amount of time. And a lot of that is because we have a director in the loop, a creative individual, who is always changing things. So if we look at the market for cinematic rendering, who needs this? It really splits down, as you see here. This actually is not a huge or enormous industry when we get to looking at photoreal images. Probably around about $160, $200 million per year. And most of that is in CAD and computer-aided design. The film and 3D animation component is fairly small, but the entire film industry now essentially relies on that capability to render these images and the sheer quantity of these images that I mentioned earlier. Likewise, architectural visualization, post and broadcast, all of them have a need for photoreal imagery. The problem is that the cost of doing this is prohibitive, certainly when you want to do large amounts of it. Stills are fairly easy to do, of course, and there are applications that can do that. But if you want to do animations at high levels of photorealism, it takes a long time. And if we classify the market, who does this sort of work? And all this is important because this directly feeds into the cloud strategy that we have adopted. And certainly, when we look at special effects and animation, there are really only 15 studios worldwide who are really big, and they're really big. We're talking here about the Pixars, of course, the Industrial Light and Magic's, Weta down in Wellington, certainly fit into that category. MPC Double Negative. There's been little change in those studios for about the past 15 years. They're heavily invested in existing infrastructure. They have large numbers of people, producing the shots and effects you see in today's special effects movies. The second tier is the interesting one. This is where the growth is. There are probably about 200 to 300 of these at the moment worldwide. When you look at the credit roll behind a movie, you'll usually see lots of names and a big block of text, which is really hard to see who's who. And then underneath that, you'll see smaller blocks of text, normally associated with smaller studios. They all fit into this second tier, and that's where the growth is. But reality is that to do the sheer number of shots and images that the tier 1 studios are doing, they need to have access to more compute capacity, and that's difficult, right? It's expensive using a physical data center. And then we have the tier 3, which is the long tail, which, of course, we're getting down to small studios, individual users, prosumers, all of those. And the reason this is shaped like a trumpet is because it's based on license volume. That is, the first tier has a disproportionately large number of rendering nodes or licenses just for the number of studios. The second tier obviously has a lot more studios, but they have far fewer rendering nodes between them. And then the long tail just goes down and down. And there is definitely also an operating system transition. Pretty much everyone is on Windows until we get to the upper sections of the second tier studios. And then most of the tier ones, in fact, pretty much all of them are Linux-based studios. Much of that is because their history goes back to using silicon graphics and other Unix-based operating systems. So I wanted to show this because this is important for how we look at addressing the market for cloud-based rendering and computing. So where does all this happen? Where do people render photoreal pixels? Certainly the ones for feature films. If we look at 2005, if we have a rendering activity monitor, kind of the heartbeat of the industry, then it's probably where you'd expect it to happen, right? This activity. You have a big chunk of stuff going on in California. London's big, a few places in Europe, Hong Kong, Japan, and a rather large chunk of rendering going on in New Zealand, pretty much all of it down in Wellington. I'm sure you will probably know most of those folks are, Weta has a very, very large data center and is one of the largest players in this industry. Let's step forwards, though, to 2010, 5 years. And in fact, you notice that the chunk representing rendering in California has shrunk. Vancouver has started growing. London has got bigger. Weta and New Zealand's added a little bit more. We're seeing new centers popping up in India and in Singapore and Korea. Then we step forward to today. The change has become quite dramatic. California has now become quite small relative to its previous dominance in feature film visual effects. We're seeing Vancouver, London, and all of these other places, certainly in East Asia, now becoming centers of production for this type of work. We're seeing a lot of globalization occurring. One of the reasons for this is because governments like to give subsidies to this work, to attract this sort of work into their territories. Another, of course, is the production of local properties. Cost and expense is definitely a big part of it. But this globalization of the cinematic production infrastructure, certainly when it comes to visual effects, is a key trend for the future because it bears directly on how different studios can collaborate worldwide on a common project or a common movie. Let's take that as an example. We're not there yet, but again, look at the credit roll behind any movie, especially those with lots of visual effects, or if it has space or science fiction or fantasy themes, certainly, you see a huge number of people in different studios and companies all working collaboratively on this particular project. So I showed this slide yesterday in my keynote. The growth in this data center size that is needed to compute these pixels is running around about 30% plus year over year. That's why just 10 years ago or 5 years ago, 5 to 10,000 cores would be enough to produce a movie at that time. And now we're up to kind of 50,000 cores, 60,000 cores in a physical data center. No longer do studios that are based in some nice boutique location in downtown Vancouver or pick up your city do their rendering in the actual studios themselves because it's hard to fit a data center of that size into a small city. So normally it goes to a remote center or somewhere else. Reality is that we apply that 30% compounded year over year to the growth trends which we continue to observe in feature film rendering, then the data centers are going to get ridiculously large. And in fact, the situation has got worse because over the past few years, there's been a change in the way movies are rendered from, without getting too deep into the technicalities, from scanline-based methods, or what are known as biased methods, to unbiased or physically based ray tracing, which essentially is simulating the laws of light to produce images that are physically real or as plausible as we can make them. But they take a lot of CPU power to do that. So that's why the curve has actually got steeper. So economics is a dismal science. You know, the size of the render farms are too, they're big, and the costs to build them are enormous. Also, you have this very big fixed physical capacity. Once you've got it, you've got to justify the expense, right? You have to keep it full, you have to keep it occupied, and it's very inflexible. Burst rendering is a fundamental part of the landscape in cinematic rendering or photoreal imagery. Everyone underestimates the amount of compute resource needed to deliver a movie on time. The result then is that you need, in the last few months, to quickly find another few thousand or 10,000 cores. So you either end up wheeling in lots of hardware or you have to get it from somewhere. Burst rendering is expensive. Something has to give. And, I covered this briefly yesterday in my keynote, but it's a really critical point that, the idea of having rental rendering services is nothing new. This has been tried many times over the past 10, 15 years, and almost with monotonous regularity, those business ventures have failed. Lots of people have spare data centers. They think, well, I could sell downtime and sell it to feature film studios. But the reality is that the demand cycle of producing movies is very erratic. It's feast and famine. It's either all or nothing, especially towards the end. So there's a high degree of difficulty in securing regular work for this type of work. And, frankly, if you're producing the tools and the software, and Pixar is a software vendor as well as a feature film studio, then, the models for licensing, for pricing, they've never really quite worked with this model of what essentially is a private cloud or a local physical data center. And of course, it's always very difficult to reproduce the complexity of all the assets that are created inside a studio remotely in someone else's data center, especially when confidentiality is critical. Always remember that in feature film work, most studios have air gaps between their render farms and the internet. No one wants to see, something in the next Star Wars movie or whatever leak out. Security is critical. So the cloud is different because the demand cycle is obviously spread across huge numbers of verticals, right? And the size of the compute infrastructure is enormous. I think if you like, almost, it's not a fantasy, but the theoretical ideal scenario would be is that if in the cloud you could submit one of those frames, let's say that those 158,000 frames I showed earlier in a typical movie, if you could submit one of those to 158,000 cores all at the same time, then in theory you could render an entire movie in the amount of time it takes to do the slowest frame. Well, of course, you have to have the right instances, you have to be able to manage and control all of that, but the sheer scale and the elasticity of the cloud is obviously significant, and it must have a major bearing on the future, especially as you no longer need to keep a physical farm busy to justify all of that expense, and you can package up essentially containers of applications and match them to CPU instances with the right amount of RAM, run it specifically for whatever number of minutes or hours you need, then shut it down. So you have an extremely economical model which can accelerate the time it takes to get the first pixel in front of an artist who's creating these effects. So in effect, everything becomes that burst rendering, which I mentioned earlier. So that's CPU rendering. What about GPU rendering? This is a question which I'm very commonly asked. We're talking about graphical images. Will people be rendering movies on GPUs? In fact, what we're looking at here in this animation, this is an example of GPU relighting or re-rendering. So we can actually refine the look and the light and the shading of Sully here from Monsters University. GPUs really fit within three categories. There is what is known as pre-visualization, which is essentially just the basic layout and blocking of the individual shots in a movie. So it's not final quality. It's really where the light is coming from, where the shadows are, for example. Then there is what we might call the more specialized pre-compute, where we use the GPUs to do what they do really well and inject that into a final software renderer. And then we have the third category, which is essentially using GPUs to render everything, the final beauty renderer, as we might call it. And the reality is that we're not there yet. In fact, even though you see amazing demos from NVIDIA and others, no one uses GPUs to render movies at the moment. There are a number of reasons for this. One is that the current physically based methods we now use, using ray tracing and certain types of effects, aren't necessarily a good match for the current GPU data model. You know, GPUs don't have a lot of texture memory, for example. There's a lot of churn with the hardware-software interface layer, right? You know, the different languages, different GPU languages, which one is the flavor of the month? And the sheer data sizes involved in rendering these movies, sometimes terabytes to petabytes of information going into any one frame, are obviously big issues. You know, so if you only got, 16 megabytes or whatever of memory or texture memory, there's not enough. And in fact, reality is that if you look at great GPU-rendered images, they only really are as good as CPU, traditionally rendered images, of maybe 4 or 5 years ago. The simple reality is that the economics of rendering movies is all about cost and, frankly, throwing CPUs and memory at it, which are very cheap. And even though GPUs get a lot of the headlines, the reality is that over the past few years, there's been a multi-core revolution, as much as a GPU revolution in the creation of visual images. And that cost and abundance of low-cost CPU instances is a major driver of the way people think about the economics of rendering these types of pictures. So it was a few years ago, around about 2012, that we decided to initiate a trial rendering service on Azure with Green Button, which is now Azure Batch. And we did this very deliberately to be able to understand what the issues are going to be, or would be, in rendering in the cloud specifically, getting away from physical data centers completely. And if you remember the trumpet I showed you earlier, we did not target this at these big studios, at the obvious ones you might think, the Pixars, the Wetters, the ILMs. Those folks are invested in infrastructure. They're not going to change immediately. But the growth is in the second tier and the third tier in the trumpet I showed you earlier. So we targeted this very specifically at them. This is a case where the economic benefits come in at the middle and are going to move up, not from the top down. So, we expected there would be questions we weren't even thinking of when we did this, and it's true, there were. And we wanted to validate a metered pricing model, which for, if you like, a software and technology provider like Pixar, which was used to licenses, which were summed in tens of thousands or millions of dollars, to think about, core hours at 13 cents was kind of a bit of a mental shift, to say the least. And these are the lessons we learned. This is kind of expanding a bit on what I discussed yesterday. Our original thinking was that there must be some granular price for rendering or this type of calculation, which would be based on a core hour, right? That kind of seems sensible. No one would think about pricing in gigahertz or hour or anything like that, but core hour kind of relates to a machine that you might be using on your desktop. But it turned out that that was not how people wanted to pay for these types of rendering services. They wanted to pay per invocation of the rendering instance or node or license. I'm going to use the term invocation in this place to represent what you might think of as a license, which can essentially float anywhere, doesn't matter what it runs on, and it can thread to any number of cores. So that obviously has a bearing on the type of instances in the cloud you're running on, because you may need more or fewer cores. But the reality is to have a per invocation pricing model is the one big lesson we learned. Secondly, the hourly pricing was much too inflexible. Everyone wants per minute pricing. Even the notion of paying per pixel came up. which, of course, would be a ridiculously small number, but when you see the numbers of pixels generated in a movie, that's a pretty attractive idea to me. And we also learned that the idea of a cloud rendering service in the Azure batch model isn't necessarily suitable for all studios, especially the big studios who, as I said, already invested in their infrastructure. And they especially needed the ability to be able to reserve fixed time blocks of compute capacity for certain periods of time, to fit their schedules and their deadlines. And the technical lessons we learned, well, clearly there's latency in the cloud when you run a task there compared to running it locally. And also just the transfer of data, getting it up, the ingress into the cloud. We're talking about, if we're talking about terabytes or petabytes of data, it's probably easier to mail a hard drive. But this was back in 2012. Obviously, these are all issues that a lot of work and people are working on at the moment. But there were factors, and also that the rendering part, our part, doesn't necessarily exist in a world of its own. There are other applications as well that have to run as well on various plugins. And if they don't run in the cloud, then you have to bake out data and upload it, which is a pretty clumsy way to work. So the compatibility of plugins were issues. Also the scalability, if you need to scale very quickly, and what the cost of that was, related to the fact that because large amounts of RAM are often required for certain sorts of shots, the most desired instances in the cloud aren't necessarily the most common ones. So, you look at the average cloud pricing compute per instance, and it's like 12 or 11 cents or something, but, it doesn't have as much RAM as the types of instances folks really need to use. And poor customer access. I showed you the globalization of visual effects. So remember, this is back in 2012 when we started this. These are the lessons we were learning then. So if you were rendering in India or in Singapore or somewhere, you may not have had as high a degree of access as you might have done in other territories around the world. So 3 years later, what's happened? Well, the cloud is being used in production today. Just recently, there was a company, Atomic Fiction, they produced 600 shots for a recent movie, all done in the cloud. It was apparent to us that when we initiated the green button trial, we actually were running ahead of the curve. We were putting out there a managed service, maybe about a year or so, or 2 years before the market was actually ready for it. But we learned a huge amount. But today, even with studios who have their own data centers, we're seeing PC over IP solutions very commonly used, and we're seeing new cloud service models, particularly the managed service models, appearing to service this second tier of studios that I referenced earlier. Perhaps one of the biggest issues we've had to deal with has been the emotional issue. Security, it's not safe, I'm going to lose it. The fear, uncertainty, and doubt associated with this type of rendering is now diminishing fast. But it has been a factor we've had to deal with. We all know that there are folks doing work in the cloud which is often quite confidential, financial data and so on. But that message is coming through that it can actually be a secure environment. Reality is that 30%, I showed you earlier, is a relentless growth trend. So as I said, there's no one-size-fits-all solution. We learned that, and the 3 models that we're currently deploying are as follows. So, I went through the trumpet earlier, as I call it. It's our little market map. We have the green button or the Azure batch model where all of your assets are created on maybe just a few machines you have on site in your own studio, and they're then pushed up into the cloud onto instances that are provisioned with the applications and have the right physical characteristics to process your data. And of course, the good, useful aspect of this model is that the vendors who fill this space separate the transaction process from the folks who actually provide the compute capacity or develop the technology, like us. And in many cases, companies or vendors don't necessarily want access to customer data for various reasons of IP and infringement and other. And Pixar's a part of Disney. We don't necessarily want to have access to information as far as other studios are concerned. So to separate out the transaction model is actually important. So this model definitely really only benefits the tier 2 and the tier 3, the bottom part of the trumpet. It has nothing to say to the larger studios who are already heavily invested. So we spent the past few years trying to figure out how best to address those folks. And the way we do this is through essentially enabling those studios to extend their existing infrastructure into the cloud itself. So they have essentially a mix of fixed instances or physical machines in the local area network, and they add on to that, essentially cloud capacity as needed. That means that we need to have the ability to serve licenses into the cloud or locally from some common source and dispatch those tasks and control them all in a consistent manner. And we're currently building that technology at the moment into the RenderMan renderer. This definitely benefits the tier 1 and tier 2 because it respects, if you like, the existing investment that has happened and these studios have put into their own local data centers, but it gives them that burst rendering capacity or expansion capacity as they need it without having to move premises or build an even larger physical farm. But let's go back to that globalization slide I showed you earlier when you saw where rendering is happening around the world. Increasingly, it's becoming very diffused. I think the ultimate way this business is going is a virtual production and render farm completely in the cloud. Here, all applications which are used to create these images run in the cloud. Not only the renderer, but the modeling applications, the asset creation, the animation tools, the plugins, all of those. And there's very little, if any, investment into fixed physical infrastructure. So, it's essentially, very thin clients. We have people working off of tablets or they're working off of a few workstations, and hopefully as fat as possible data pipes into the cloud where all the compute and activity to create these images occurs. Essentially, you have a whole chunk of self-provisioned containers, if you like, containing all the apps. And all this works remotely, happens remotely. And because there has been a parallel move to build common standards so studios can interchange assets between themselves on common projects, then that supports this model as well. So we can see a lot more collaboration going on in the cloud. So this essentially is everything in tier 2, tier 3, but I think it will move into tier 1 as well, into the larger studios. So that way, we have essentially an entire production pipeline in the cloud where we essentially meter how much is used on a per-minute basis. The whole rendering ecosystem is containerized. Everything is assembled through software components. We're using tools like Docker or Tractor, which is one of our own tools to manage all of this. And the licensing of all of the software components is servable from a single source and across all elements of the pipeline. And we really have two models. We have the cell phone analog, whereby we're either essentially tracking the usage almost like a cell phone, so studios are just sending us or paying for the amount they use, or maybe a more bundled component, a package where the CPU and all of the tools, everything is combined into one bill, if you like, at the end of the year. So business trends. So the key drivers of the business, as I think has become clear, I hope, from what I showed earlier, are the globalization of visual effects and the terrible economics at the moment of building physical infrastructure. The fact is that as soon as that barrier to entry, which is the current cost of producing all this material, is removed by making it easily accessible through the cloud, then we can grow this industry quite healthily, especially in the second-tier studios, which is really, as I said again, where the growth is going to occur. But there are issues that remain. Asset management, certainly across collaborative projects in the cloud, that is certainly an issue that is not yet properly addressed. Serving some aspects of licensing, especially licensing in the cloud. These are issues that people are working on at the moment. getting the right price, and all of the security issues associated with satisfying the bodies in the film industry, like the Motion Pictures Association and so on, which are written into the contracts of the studios who work on these films that they will obey. So to summarize, before we kind of go into a Q&A, what are the trends technology-wise? There are still challenges technically. The compute requirements for this type of rendering work are often a little different to mainstream cloud computing requirements. They need certain types of instances, certain amounts of memory, certain types of machinery underneath. We're really talking about data that is extremely unique, very valuable, right? It has to be kept very confidential, and endless numbers of tweaks that are applied to all of these shots that you see. There's always a director in the loop, and the director is always saying, change it, make it a little greener, make it a little bluer, lighter, darker, and we'll go on and on and on until finally, 60 iterations later, that level of almost perfection has been reached, but never quite is. So you can imagine if you could render every frame in the cloud at once and render the whole film up to the last frame, then maybe the director would make changes up to the last day before it was released. I said, well, I'm sure it wouldn't happen like that, really, but you just follow this line of thought to its logical conclusion, and that's where you end up. Okay, also, there are some data models in rendering films. Certainly, when you're doing with what's known as procedural data, these are kind of simulations that occur that aren't necessarily matched to the cloud model. A simulation, certainly a physical simulation, is a deterministic type of situation where one thing has to follow another. It's not necessarily parallel. And the elasticity of scheduling, the time it takes to start up and shut down times in the cloud, we've encountered this as an issue on the technology side as well. But there are solutions. The reality is that many tech vendors are working on these problems at the moment. Thin clients, fat data pipes, I think, this is where even our business is going. And, the globalization of visual effects production will lead, I think it must lead to a more diverse, multi-studio approach to many of the very large-scale visual effects productions that are produced today. And this will be helped by common standards. Pixar has announced an open source initiative called USD, or Universal Scene Description, that enables you to share entire scenes and shots of the complexity you see in a movie between different studios. We do this deliberately to make it easier to pass data around and share it within a huge, large environment or compute environment such as the cloud. So that's kind of, to wrap it up, I think I've got about 15 minutes or so, or a few minutes, just to answer some questions. I wanted to really expand upon what I covered yesterday in the keynote and kind of open it up now to see if anyone would like to ask any questions about our experience of doing this. And there are some folks with microphones, if anyone does have a question. I think there's one question up there, and there's a mic. So.
Hello. How big of a role does Docker containers play in Pixar's renderment service?
Well, at the moment, we're literally starting. So as of today, not much, but that is an element of where we see this whole business of controlling large numbers of apps that need to be coordinated within one container in the cloud. So yeah, it's one solution.
You talked about security and the perceived lack of it to a lot of people you deal with. How are you actually addressing that?
Sorry, I missed the end of the question.
How are you actually dealing with people's view on security in the cloud to bring this product into the cloud?
It's been a challenge. As I said earlier, there's a lot of emotion and fear, uncertainty and doubt associated with this. I mean, there are various technical options one can apply to make the data more secure. You can tile imagery, for example, so that only small fragments of an entire image are ever actually accessible from any one portion of the cloud. So no one can ever actually reconstruct the final data as would be seen. So you're not seeing, what some unreleased movie would actually look like. There's the experience of other vendors in other verticals, nothing to do with feature film work, especially in the financial sector, for example, and how they've implemented security that we're learning some lessons from. I think our perception is that the issue is overstated. There is more concern over it than is probably warranted at the moment. But I'm sure all of you have probably heard of the terrible hack that occurred at Sony Pictures, right? Which is central in our business. They're one of the big 15 studios, and they lost huge amounts of data. So there is still a strong emotional component. And, we're having to find the best technical solutions to overcome that. And part of it involves literally decimating the data in various ways, so it's not accessible or you can't reconstruct what you get if you only access a part of it. Any other questions?
Is this thing on? Oh, here.
Yeah, you're live.
So you referred to like a zero cost model for and hobbyists, I think.
Yeah, it's certainly accessible to them.
Yep.
Yeah.
What's the sort of, you referred to some monetization streams that come in on the back end of that or something. Can you expand on what you meant by that? Or is it just, if you're not doing this for money, fill your boots and use it for free?
I think what you're referring to was a slide that I didn't include here, but I covered this yesterday in my keynote, which is that we have made our rendering technology freely available for non-commercial purposes. So anyone can download a license, if you like, of the software. You could do this. Just go to our website, and if you're running Maya or some, asset creation tool, you can use the same renderer that we use or most visual effects studios use to generate their images. And we've done this deliberately to essentially democratize this rendering technology and break these, if you like, bonds on the growth of the industry, which has existed to date. But one way we can monetize those licenses, of course, is through the cloud. So if you're a hobbyist, for example, and you have your Maya license and you have a RenderMan license, and you want to generate, not an entire movie, but maybe a short film or something, just using, let's say, 100 hours or 500 hours of cloud time is not that expensive. It's really cheap at the price levels we've established. So it's just a way of thinking about how you can use the cloud to monetize a capability that's traditionally only been made available through the license, which is kind of a rather 90s way of thinking about making software available.
The hobbyist doesn't pay anything for the license, but they do pay for the use of.
So they essentially pay for the compute cycles to generate that material.
Okay, right.
Yeah, and there's a margin model which can be associated with that. Yeah.
Okay, and they can do all that through you, though. They don't have to go off and do something separate.
Well, they can do it through us. They can do it through third-party vendors whom we have a relationship with. As I said, there is actually no one way of doing this, and we have a whole series of different options on the table to make that available.
Cool, thanks.
Yeah. Okay, I think we're coming up to the deadline, but there's another question there, so I'll just keep going.
Yeah, hi Chris.
Hi.
Have you detected any signs of Weta trialing, looking at piloting, investigating cloud rendering?
Well, I can't speak for Weta specifically, of course. Though, I know them very well. Weta is notably very heavily invested in a very large data center down in Wellington. I've been to it. It's quite impressive. And, that's a heavy investment. And, to my knowledge, at the moment, they're rendering most things in-house or everything in-house. If they've been trialing substantive material in the cloud, I've not heard of it, actually, yet. But as I said, I can't speak for them, so it's possible there's something going on that I'm not aware of.
Hi, Chris.
Yeah, hi.
Just a question about the assets that you mentioned earlier, that they might be the size of terabytes to generate these renders. How did you get over the problem of the data transfer and transfer speeds? Also, what happens to these assets after the frames have been rendered.
So, I mean, to take the second question first, that of course directly relates to the security concern, right? That data should not be lying around, right? Once it's actually finished. However, to go back to the first question about the size of the data assets, this actually is one reason why we did not target our initial trial at the large studios, who generally are the ones who are working with those extraordinarily large data sets. Generally, the smaller studios working on smaller shots are not working in petabytes of data. Their data sizes are far more manageable. And, you know, it was our expectation, and we see this, you know, that the technology to enable very large uploads of data would evolve and is evolving at the same time, you know, using multiple FTP streams and, you know, various tools like this. So, you know, this is all a technology in progress, right? A work in progress at this point. But I think ultimately, you know, that these are the data sizes that we have to be thinking about. And those asset sizes have been growing as relentlessly as the amount of compute, you know, needed to render them. Yes, sir.
Yeah, hi. A big part of filmmaking is ascertaining costs. You know, even pre-applying for getting funding. You know, for promoting projects. Is there a way forward to ascertain the overall costs that are rendering a project that would
yeah, that's actually a very good question. You know, the question is there a way of ascertaining how much this costs? In fact, you know, one of the issues with a metered pricing model is, you know, how do you contain it? If you're the producer of a film, you know, you're the business manager of the film, how do you make sure that your budget doesn't go crazy? Because the director will just keep spending money until he finally gets the look he or she wants. So the reality is that when you're rendering in the cloud, invariably you will average out, first of all, what the general render times for the types of scenes and shots you're working on are. In fact, Green Button or Azure Batch actually have built some tools with some heuristics that kind of make some assumptions and will kind of attempt to help you get a sense of the number of frames, times, the complexity of the shot, and how long that will take, plus some other variables in the equation. But the other way of doing this is ultimately, and I mentioned this in one of the slides, studios will actually prefer to block out entire chunks of time in the cloud that are priced in advance and which they can build in some high degree of confidence that they can get the project done within time. But this model is still evolving. You know, the technology and the business are both in flux at this point in time. And if there's one thing you take away, I hope, from this presentation, is that you know, we don't have all the answers yet. You know, I've tried to give you a sense of what the main considerations have been that we've had to deal with. And some of these issues are not yet fully resolved. Yes, studios are now using the cloud. They're rendering the clouds and churning out shots. But every studio has its own, how to put it, degree of self-discipline when it comes to pricing out how much time they're going to allocate to each shot, you know, to get it to what they hope is a finished state. So that's probably not a full answer to your question, because there isn't actually a definitive answer to it. It's all of this is really generating new ways of thinking about how you price out and how you build these films in a new type of infrastructure. Okay.
In the medium to long-term future, is the ultimate limit on the quality of the rendering or the photorealism going to be the computing power of the cloud or the algorithms?
Okay, that's an excellent question. Generally, if the path to photorealism, you know, you could generate a completely photoreal scene that you can never distinguish from reality, was linear, we'd have all gone home 10 years ago. Problem solved. It's not the case. It's an asymptotic curve. You know, each percentage of detail you eke out takes almost as much effort and time as it took to get to that point beforehand. You know, a common philosophical discussion we have is, you know, is there a time when a rendered image will be good enough? You know, it's like, it's done, it's real, we can't make it any more real. But the reality is that if we get to that stage, and we probably will, the games industry will continue to drive GPU development. There'll probably, under the 80-20 rule, be a time when the quality of a photoreal image will be pretty outstanding. But of course, we're dealing with a creative discipline here. Directors, people who work in this business don't want to do everything that looks the same. They will look for new looks, they will look for new visual ways of expressing their creativity. And there are still major areas of rendering, lighting, that are still not properly resolved. That the health of any technology endeavor can be judged, one way to judge it is by the amount of research which goes into it. SIGGRAPH is the main venue for publishing research into computer graphics. Just happened a couple of weeks ago in LA. Very, very healthy. Large numbers of papers addressing all sorts of problems in rendering. Areas like volumes of gas and polarization. This is not a mature or totally mature technology on the S-curve, if you like, yet at this point in time. So, the basic law, which I mentioned yesterday in my keynote called Blind's law, that says a frame always takes a certain amount of time, no matter how efficient the algorithm or no matter how fast the compute capacity required to do it, has always remained true over 30 years and probably will do for some time yet. Okay. So, any other questions? Or I think we're probably going to start colliding with the next session. So, going one, going twice. Thank you very much, everyone.